Good afternoon, stats. This is actually our Tuesday lessons. This is just a recap of 1.3, which hopefully you saw some notes on through the Khan Academy. Now I just want to recap all of that, just so you have a good idea of what we're doing in this. And then your job today is going to be doing some Khan Academies, and then we'll work through a group problem together. I'll push another video out on working through that. And that's kind of it. And then we're going to have a bunch of Khan Academies that are then due for the next class, which is then a review class to get us ready for a little bit of an assessment as we do that. Again, strange week, but this is asynchronous, so that means you kind of do it at your own pace and kind of pause it when you need to and do that kind of sort of thing. So let's dive right into 1.3 is the big basics that I really want you to get out of this thing. So 1.3. We're really going to talk mostly box plots here, which is another type of plotting, right? We did dot plots, we've done stem plots, we've done histograms. We're still working with quantitative variables. So box plots are good, especially when, like, if I did dot plot. So I have a data set here. This is like the top 20 NBA players by their height, right? So they said, like, who is the best 5'8" player in the NBA history, I guess. I don't know. It came from a website. This is where they kind of believe that these are the best players at that height. The problem is when I take all those height and I would try to put these on a dot plot, it'd just be a flat line of dots, right? No real raise to them at all. So it doesn't really help us to do a dot plot of this. Stem plot's going to kind of have the same effect. It's not going to be super beneficial to us. Histogram would be great. It'd be great to do a histogram on this so we can kind of see where these 20 data values lie. But you would anticipate kind of a pretty fairly symmetric graph on this. But box plots are just another way to assess. They kind of help us do the same thing, but it breaks it down into quarters. Like a quarter of the data is in this range, this range, this range, and this range. All right, so that's what a box plot does for us. So the first thing you want to do is take a data set like this, and we just want to input the data, and then we're going to go find different values. So what I'm going to do actually is, since it's already in order from least to greatest, and so you have 5'8", Willie Somerset, up to Yao Ming, which is 7'6", but then you see on the other side, I went ahead and changed those all to inches. So 5'8" is the same thing as 68 inches. If you look down to a 6 foot tall, is the same thing as 72 inches. Right, a 7 foot tall is the same thing as 84 inches, right? So I already just put those in the inches for us. So they're already least to greatest. So 20 different values here. So here's what I'm going to do this all by hand. Not that I would all the time. Sometimes I just do right in a computer calculator and get it done. But let's just do it right by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oscar Robertson is the 10th player, making Michael Jordan the 11th player. So if I did above Oscar Robertson, there's 10 players. Michael Jordan below, there's 10 players. So actually, the median of this data set is the average of the two middle values. Since there's two middle values, we got to average both of those, and there's your middle value. So it's going to be 77.5. Okay. So I'm picking out some key elements here. Minimum value, maximum value, we'll find in a second. So I'm going to do Q1, quartile 1. Quartile 1, we're going to take the upper 10 values. I'm going to find the middle value of the upper 10. Well, again, since it's the even number, 1, 2, 3, 4, 5, I want to find the Q1, which is going to be the average of these two, right? Because there's two middle values in the upper half. So it looks like it's going to be 72.5. I'm going to do thing 1, 2, 3, 4, 5. Moses Malone and Tim Duncan. In between them is your Q3. Looks like we're going to get 82.5. And let's round this thing out by taking the maximum value and the minimum value. Okay, so those 5 numbers there is appropriately called the 5-number summary. 5-number summary is the minimum, the Q1, the median, the Q3, and the max. The median, remember, has a name called the Q2. The second quartile is also known as the halfway point or the median. So those are the different numbers that we have. So I'm going to build a box plot by hand. And again, we don't do a whole lot of things by hand, but sometimes I just like to just show what it would look like if I did it by hand. So I'm going to do like a number line here. let's see, we got to go from 68. So I'm going to actually go 65. Then we got to go up to 70 or 90-ish. So it's sorry, 87. I don't know why I said 75. 75, 80, 85, 90. Okay, so that's what that would look like. So now let's just go ahead and I'm just going to readjust some things real quick for myself. Let's do this. Let's go and put the dots above where each of these are. So I got a dot at 68. That's the minimal value, sorry. At 72.5, so about 73. At 77.5, that would be about right here. At 82.5, that would be about right here. And then at 87, that would be about right here. So I'm going to put a dot above each of those 5 numbers. Now, where the Q1 is and the Q3, we are actually going to create a box. So the box of the box plot is actually the interquartile range, right? You kind of see the interquartile range. And then you put a line right in the, or wherever that box is, wherever that median happens to be inside that box. Now you will find sometimes that the median is right on the edge of a box, on either edge, or it's just slid in there somewhere. And then we're going to just draw these little lines out to the edges. These are called the whiskers. Typically, we'd call them box and whisker plots. And there it is, right there. That is a box plot. Now, what's key about a box plot is 25% of the data lies in that range, 25% in this range, 25% in this range, and 25% in this range. So that is a how much of the data, the values lie in there. Now, since this is an evenly spread, right, it looks very, very symmetric. There's maybe a little more length over here to the right, but that gets us kind of to the actual spread of the data a little bit. So that is the box plot. Now, what you'll do is also there's a thing called a modified box plot where you show outliers with dots, right? So let me get to that in a minute. But let's just say this for now. There's your box plot. Remember, it breaks the data into different quarters. How much of the quarter? Sometimes they'll say, what is the middle 50% of the data? The middle 50% happens to be right here. It's the box, right? 50%. Sometimes they'll say, hey, what is the 75th percentile? And the word percentile, which we'll really get into in chapter 2, but it just means how much data lies below. So you could actually cut this thing off right here and say that truly 75% of the data lies below that value right there, or the Q3, third quartile. 3/4 is 75%, right? See how kind of all goes along together on that stuff. So that's what you get right there, doing that. There's your box plot, basic box plot. It's another beautiful graph that we can make that shows the data values as they are. Okay, one of the other big things, once we build this thing, we're always going to be looking for socks, right? So if I said describe the data set, we're going to say, okay, what do I know about socks? Shape. Shape's a little harder to find in this. I can definitely tell, like it's I don't know exactly where the mass of the data would be, but right, something like that. I'm trying to always estimate what would it look like. So really shape, best to talk about shape on a dot plot, stem plot, or histogram. But on this, you can still get, you can tell if there's a skewness out to the right here, right? Because it would come out further on this whisker, or skewness to the left. You'd see a longer whisker on the left side, right? So we can definitely kind of see if there's that. This is looking kind of symmetric, right? So when we talk about describing shapes, symmetric. Let me skip real quick. Let me do center. Center is going to be easy to identify in this because you're just going to be looking for the median value, right? As long as you can find that on the graph. Wow, I missed that. On the graph, it would be there, right? The median, 77.5. Let me report it. There is my description of center. How about spread? Well, spread, remember, if I am going to use the median, we're going to use its partner, the IQR, the interquartile range. Well, remember, the interquartile range is Q3. Let me actually do this. IQR equals Q3 minus Q1. So in this case, Q3 is 82.5, Q1 is 72.5. It looks like our interquartile range happens to be a range of 10. That is the IQR right there. Perfect. So if we use median, use its partner IQR. If you happen to use the mean, which would be okay to do, but except for a box plot naturally lends itself to a median because I can see it. But if you happen to use the mean, which is totally fine, add them all up, divide by whatever you got to get your mean, then we want to use the standard deviation to partner with that guy. Okay, so that's what 1.3 box plots doing that IQR. All right, so let's get back to this. So this is really the one I want is outliers. So in the video, you use a thing called the 1.5 times IQR rule. 1.5 times IQR rule, right? It's also known, right, AKA outlier rule. So actually, if you remember this thing by the 1.5 times IQR rule, you actually have the math down. But this is essentially what it says, is if I take 1.5 times the IQR and I add that to the Q3, it gives me the upper bound. It gives me an upper bound of non-outliers. Now, if I took Q1 and subtracted 1.5 times IQR, it gives me the lower bound. So it tells me, like, if I'm upper bound to lower bound, if I am in this bounds, it's not an outlier. If it's beyond those bounds, it's an outlier, right? It's too far away from the group. It's an outlier. So let's try it here. Here's a little bit of algebra for you. That's why this is prerequisite for the course, knowing a little bit of algebra. Good night. Come on, man. All right, 10 is the IQR. So if I did 1.5, I'm just going to do it out here to the side. 1.5 times 10, that equals 15. So I'm going to do this upper bound, lower bound. So 15, that's 1.5 times IQR plus the Q3, which happens to be 82.5. If I do that, we get what, 97.5. So 97.5 inches. And then if I did Q1, which is 72.5, and subtract the 1.5 times IQR, which happens to be 15, that equals what, 62 minus another 5, that would be 57.5. Okay, so 57.5. We now have our upper and lower bounds. So then what we do is literally look at all this data set here, right? Are any values lower than 57.5? If they are, they're outliers. Are any of the values greater than 97.5? If they are, there are outliers. In this, no outliers. No outliers in this set, okay? So that's what we have, that's box plots. Can I build it? Can I read it? And then at the end of the day, can I do stocks, shape, outlier, center, spread? This is the calculation for outliers, 1.5 times IQR rule. Sometimes in outliers, if we're doing a quick assessment of a graph, we're just going to identify what we believe to be an outlier, right? Those values that look like they stray from the group. Now, if they ask us to confirm outliers, we got to use the 1.5 times IQR rule in order to do that, right? Center, mean or median, and then spread is IQR, standard deviation. Make sure that you partner them with the right measure of center. And then shape is shape. Again, box plots aren't the greatest for assessing shape. We can get a slight sense of what's going on, but our best assessment for shape is going to come from a histogram, a dot plot, or a stem plot. Also do know that this data can be done on a calculator. Like box plots are part of the calculator programs, but also part of any kind of computer programs. So feel free to use those as well, because that will be beneficial to you as well if you just need to make these things and assess them. But here I wanted to at least show you, can I find the median? Can I find Q1, Q3 all by hand? Build a box plot by hand. This is a great little set to do by hand if we needed to. But we also have calculators, computers. Feel free to use those as well. So that's 1.3. Your job is going to be doing some Khan Academies now, kind of getting those done. We'll come back and we'll work on a problem together. Okay, there you go.